Now the next is your types of adsorption. Now types of adsorption is, one is your physical adsorption or physisorption, we can say that, or van der Waals adsorption, and the second is your chemical adsorption or chemisorption or Langmuir adsorption. Now the next is, what is physical absorption or physisorption? When a gas is held adsorbed on the surface of a solid by van der Waals forces, weak force, mind it, without resulting in the formation of any chemical bond between the adsorbate and the adsorbent, is called physisorption. We can say that. That is when a gas is held on the surface of a solid by van der Waals forces without resulting in the formation of any chemical bond. No chemical bond is being formed between the adsorbate and the adsorbent. Got it? No chemical bond is formed. Simply a van der Waals force of attraction is taking place. Got it? So no chemical bond, mind it. So that is called as physisorption. That is known as, or van der Waals absorption, we can say that. Now what are the characteristics of physical adsorption? You can write it down. Point number one, it's a physical change. It's not a chemical change because no chemical bond is taking place, formation is taking place. It is non-specific in nature. Got it? As van der Waals forces are universal on every solid adsorbent. Got it? So hence it is non-specific in nature. As I said, van der Waals forces are universal on every solid adsorbent. Every gas is adsorbed, only the extent of adsorption may vary. Any gas can adsorb on any surface and may form van der Waals forces. The only thing can vary is the extent of adsorption, which we have already discussed. The extent of adsorption can vary from surface to surface. We have already said you, like I said, charcoal, activated charcoal, water, simple load. So it will vary. Got it? But otherwise the gases will be adsorbed on the surface. Got it? So hence it is non-specific in nature. Now next is the nature of adsorbate. As already explained, easily liquefiable gases having high critical temperature are absorbed more strongly because they have stronger van der Waals forces of attractions. Got it? So it is reversible in nature. Got it? It's reversible. How it is reversible? Because as I already said you that this when the adsorption is taking place, the heat is evolved. If you increase the temperature, then the reaction becomes reversible. So the temperature has to be kept low because the reaction is exothermic in nature. Got it? Yeah. Now next is low enthalpy of adsorption. As physisorption involves only van der Waals force of attraction and no chemical change, the process is exothermic, but the enthalpy of adsorption is quite low. And the next is surface area of the adsorption. The adsorption increases with increase in surface area of the adsorbent. Very simple. So these are the characteristics of physical adsorption. That is, it's a physical change, it is non-specific. Nature of the adsorbent already I said you. Then it is reversible in nature, it has got low enthalpy of adsorption, it has got low activation energy, and the adsorption increases with increase in surface area of the adsorbent, we can say that. Got it? So this is about your physical adsorption or physisorption. Next is your chemisorption. When a gas is held onto the surface of a solid by forces similar to those of chemical bond, the type of adsorption is called chemisorption. Here, that is just like a chemical bond. The adsorbate is held together by the adsorbent. Then it is known as chemisorption or chemical adsorption, we can say that. Alright, when a gas is held onto the surface of solid by forces similar to that of chemical bond, a new bond is being formed, we can say that. Clear? So that particular adsorption is called chemisorption, we can say that. Got it? So in chemisorption, the forces operating in this case are similar to those of a chemical bond. Already I said you. So the heat of adsorption is usually high, about 40 to 40,000 kilojoules per mole, whereas in case of physical adsorption it is low, 20 to 40. Because no chemical change is taking place, no chemical bond is being formed. Got it? In physical adsorption, no chemical bond is formed, so heat of adsorption is low. But in case of chemisorption, the heat of adsorption is high. So this is a difference I'm saying you. Mind it, it's a difference. You can note it as a difference also, this one. Then no compound formation takes place in case of physical adsorption. But in chemisorption, as I said you, a bond is being formed. So definitely new substance is being formed. Surface compounds are formed. Surface compounds. Got it? Now the chemisorption is irreversible because definitely a new bond is being formed. Got it? That is, but in case of physical adsorption, in that is physioption, we can say that process is reversible. Already we have seen it. Now in case of chemisorption, it requires no activation, it requires activation energy because chemical bond is being formed, new forces are being developed, but it does not require any activation energy. Just now I said you low activation energy, rather I should say that. Then just now we have read it, physical adsorption is not specific in nature. All gases are adsorbed on all solids to a different extent, we can say that. Clear? The rate of adsorption is different. Clear? But it is adsorbed on the surface of all solids. But this type of adsorption first increases with increase in temperature, then the effect is called what you can say effect activated adsorption. Alright, this type of absorption first increases increase in temperature, then after that it decreases, we can say that. Alright, and as I said you, it is what I can say, it is specific in nature and occurs only when there is some possibility of compound formation. Definitely, just now I said, na, first it increases, then it decreases, and it is specific. Why it is specific? Because where there is a chance of chemical bond formation, a new bond formation, there is a possibility between the gas which is being absorbed and the solid adsorbent, then only this forces is going to take place, this chemisorption is going to take place, we can say that. Got it? It forms unimolecular layer. Which one? Chemisorption, a single layer. But physical adsorption, multi-layer, number of layers it can form. Physical adsorption, like when what you can say, nickel, platinum, palladium adsorbs hydrogen gas on its surface, that is called physioption, we can say. Number of layers it forms. Got it? Clear? And now chemisorption, it increases with increase of pressure. Now physical adsorption, listen carefully, it also increases with increase of pressure. So this is a similarities. Till now I am saying the difference. Now similarity also you see, it increases with increase of pressure. Got it? And physical adsorption also, it increases with increase of pressure. One more similarity, that is it also increase in surface area of the adsorbent. Got it? Physical adsorption as well as chemical adsorption increases with increase in surface area of the adsorbent. I told you similarities as well as differences. Again I repeat the similarities. It increases with increase of pressure, both physical and chemical adsorption, and it increases with increase in the surface area of the adsorbent. So note it down, the similarities as well as differences. And if you ask me the characteristics of chemisorption, I have already discussed with you. It is highly specific, it is a chemical change, it is irreversible in nature. Just now I said you, it requires high activation energy because as chemisorption involves a chemical reaction, it is slow at low temperature, means at room temperature, so it requires some activation energy, some high activation energy to reach to the threshold level. Already we have studied about it. Alright, and it is unimolecular layer of adsorption is going to take place. High heat absorption is there, and it is highly specific. Got it? We can say that. Clear? So all these are nothing but the this what you can say characteristics of chemisorption. Once again I can repeat, you can write it down. It's a chemical change, it is highly specific in nature, that is it is irreversible in nature, high activation energy is involved in it, high heat of adsorption is involved in it, and when the chemical bond is taking place, when the gas is adsorbed on the surface, it is a unimolecular. Got it? Got it? It's the unimolecular layer of adsorption is taking place. So these are the characteristics of the chemisorption, we can say that. Now if you ask me about the application of adsorption, it is used in gas masks. All gas masks now, corona time, all gas masks are devices containing suitable adsorbent so that the poisonous gases present in the atmosphere are preferably adsorbed and the air for breathing is purified. Of course the gas mask which we are using in corona is different from the gas mask which is being used. The gas mask which is being talked here is not the gas mask which are using now. Got it? It is not that particular gas mask. Gas mask is that the person, those who are going, suppose fire is there in a building, or suppose they are going to a particular area like inside the mines or something like that, so there they use the gas masks. Got it? So there it's the adsorption phenomena is taking place. In clarification of sugar, just as I said you, that is yellow color sugar is being converted into crystalline white colorless sugar. Got it? In curing many diseases, some drugs can adsorb the germs on them and hence kill them and save us from diseases. So in curing diseases. Then in the separation of the inert gases, different inert gases are adsorbed to different extents at different temperatures, and like on what you can say this coconut charcoal, we can say that. So this forms the basis of the separation of mixture because different inert gases are adsorbed to different extents at different temperatures on coconut charcoal. Now next is in softening of hard water Alright, the use of ion exchangers for softening hot water, alright, is based upon the principle of this adsorption only. We can say that, just like chromatography. Clear? So in this way, in many different purposes, it can be used in gas mask, in curing diseases, in water conservation, in softening hard water. Got it? In there is separation of the inert gases. Got it? In clarification of sugar and so many others. So these are the uses or the applications of adsorption, so to say. Clear? So this is about, that is, physioption, chemisorption, and application of, that is, adsorption.